Okay, class, picking up where we left off at, we need to take the square root of both sides. We will have c here, and the square root of 116. There is a perfect square in 116, which is 4. And 4 is the highest perfect square. So it'll be 4, square root of 4 times the square root of 29. Square root of 4 is 2, times the square root of 29 is equal to c. Now we go here to b. You notice we have b and c, but we don't have a. So we have a squared plus b squared equals c squared. A we don't have, but we do have b, and c is 12. So we have a squared plus 36 is equal to 144. Now we're going to subtract 36 on both sides. And we'll have a squared is equal to 108. And now we need to take the square root of both sides. And we'll have a is equal to, now the highest perfect square in 108 is 36. So we have the square root of 36 times the square root of 3. The square root of 36 is 6 times the square root of 3. And that's it. Okay, class, I drew a sketch of this here. This is a little crooked. It should actually be straighter here. But this is what happens. Bill is flying a kite. He has 85 foot of kite string out, and the kite has blown 24 feet away from him horizontally. And you know horizontally is straight across. How high is the kite? So basically, when you stand and fly a kite, it goes at an angle. And then here it says it's 24 feet away. So this right here would be your 90-degree angle. So this 85 feet is your hypotenuse, and this 24 feet here is one of the legs. So we need to find the other leg. So we'll do a squared plus b squared is equal to c squared. Now we don't know what a is, but we do know that b is 24 and c is 85. Now 24 squared is equal to 576, and 85 squared is equal to 7,225. Now we're going to subtract 576 on both sides, and we will have a squared is equal to, now when we subtract this, we know we cannot subtract 6 from 5, so this would be 15. This will become 1. 15 minus 6 is 9. 7 cannot subtract from 1, so we borrow 1 from here. So we have 11 minus 7 is 4. And we'll need to borrow 1 from this 7. And 11 minus 5 is 6. And we'll bring down our other 6. So we have a squared is equal to 6,649. Now we would take the square root of both sides. And that would give us a is equal to. Now we're going to change this equal sign here to an approximation, because the square root of 6,649 is approximately 81.5. And since we have this is feet, so the height will be approximately 81.5 feet. Now we go down here to example 8. It says a square flower bed is to be enlarged by adding 2 meters on each side. If the larger square has an area of 144 square meters, what is the length of the original square? Okay, so first of all, let's draw the larger square. I guess. As you can see, my drawing skills isn't exactly the best, but we know one thing about square: all sides are equal. Now we don't know from the original square, we don't know how much this is. So we can make one side x, and all of these sides would be x. And all of these sides would be x plus 2. Now we're told here that the larger square has an area of 144 square centimeters. What is the length of the original square? So we'll do the area of the larger square, which will give us area is equal to length times width. So the area is equal to, we have x plus 2 times x plus 2. Now, we know that the area is 144. And x plus 2 times x plus 2 is x plus 2 parentheses squared. Now, we can use the square root formula. We'll take the square root of both sides. The square root of 144, we know is 12. And it equals to x plus 2. Now, we don't use the negative 12 because that would give us a negative answer, and we know we don't have a negative distance here. So we would subtract 2 on both sides, and 10 is equal to x. So if 10 is equal to the x portion here, that is the original side here, because it says what is the length of the original square. So this 10 is the length of the original square. So it'll be 10 meters is the length of the original square. So this would be your final answer. Because it didn't ask you for the area, it just said what is the length of the original square. So 10 meters is the length of the original square. Okay, now objective 3. Now it says find the distance between 2 points. Using the Pythagorean theorem, we can find the distance between 2 points, x1, y1, and x2, y2. Use a sketch to derive the distance formula. I took the liberty of putting this here for you. We start off with, you're used to seeing a squared plus b squared equals c squared first, but I just turned it around. So it's c squared equals a squared plus b squared. Now, what changes here is our a squared and our b squared. Now remember, whenever you're trying to find a distance between 2 points, you're trying to find the difference of those 2 points to find out what the actual distance is. So what we would do is we would start with the second point, which that would be the further distance, because you have your starting distance and then the distance that you went to. Just for example, if you was driving a car and you were trying to find how many miles per hour, what you would do is you would see where you started at as far as the miles you had, and then you would go the distance that you went, and you would take the new mileage minus the old mileage. So this is where we get the x2 minus x1, the new mileage minus the old mileage squared. And then we would take y2 minus y1. So y2 minus the original distance, and that's squared. Now, if you notice, I wrote this twice, but I wanted to show you this here. Our next step after we wrote this out is to take the square root of both sides. Okay, so now we have the square root of both sides, and that leaves us c is equal to the square root of, matter of fact, let me make that a little better here. Okay, c is equal to the square root of x sub 2 minus x sub 1 squared minus y sub 2 minus y sub 1 squared. And actually, this is supposed to be a plus sign in between them. Okay, so now, this is our distance formula. We derived the distance formula. Now, when they ask us to sketch a graph, what the graph is going to look like, and I'll just tell you, because, I'm not that good of an artist, it's going to look more like a triangle. So what this would be is your x1 and your y1. Your x1 and your x2 would be the difference of these 2 points here, and your y2 and y1 would be the difference between the 2 points here. And then you would be trying to find a hypotenuse, which would be your distance between those two values. Okay, now we scroll down here. I wrote the distance formula again, but this time we replace c with d, because that's what we use for the distance formula. D is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Now we have this problem here where we could substitute. Now we have d is equal to the square root of parenthesis. We'll take x sub 2. So right here, x2 is 4 minus x1 is negative 4 and that's parentheses squared, plus, we have in the other parenthesis, we have y2, which is 17, minus y1, which is 2, and that parenthesis is squared. So now, 4 minus a negative 4 will give us 4 plus 4, which is 8, and that's squared, plus 17 minus 2, which give us 15, and that's squared. 8 squared is 64, and 15 squared is 225. We have d is equal to, this would be the square root of 64 plus 225 is 289. Now the square root of 289 is 17. So your distance is 17. And we're done.